Hello, how are you all? I wish you all a very warm welcome. So let's start with the new topic. Lesson is same, the states of matter, and the topic which we are going to cover under this is the gas pressure. The learning objective is to be able to explain the gas pressure. Students, you remember well that we have done the three states of matter, that is solid, liquid and gas. Can you just recall the particle nature of solids and liquids and gases? Can you recall what is the type of movement these three states of matter have in their particles? Which particle hits the container most? Which particle exerts more force on the walls of the container? Think for some time. You can take the help of the picture or the animation being displayed right now in front of you. Just observe which particle is hitting the walls of the container most of the times. So you all can see that the particles from inside the container, due to large space between them, are moving here and there. When they move here and there, they hit the walls of the container. They hit they hit all around the walls of the container. This hitting causes the pressure inside the container. This is called as the gas pressure. If this hitting was done by the liquid particles, it will be called as liquid pressure.
Who didn't like playing in ball pits when they were a child? Now let's imagine a room filled with these balls constantly moving around in different directions. This is how molecules in a gas move. In this video, we're going to discover more about amazing gases and the effect temperature and pressure have on them. Have you ever wondered why the cork explodes out of a champagne bottle? Or the fizz when you open up a shaken bottle of Coca-Cola? This is all to do with gas and pressure building up inside the bottles. So let's have a look at pressure in gases in a little more detail. Gases exert a pressure on any surface which they are in contact with. The more particles that hit the walls of the container, the higher the pressure. Like when you shake a Coke bottle, and as it fizzes, the bottle feels harder than before. This is the gas particles pushing against the plastic bottle. So we have the equation. Pressure is force per unit area. We also see the effect of pressure in gases when we blow a balloon up too much, and it pops. This is because we've increased the pressure of the air molecules pushing against the rubber balloon too much. Heating also increases pressure. Why is that? As a gas is heated up, the particles gain more energy and move around more quickly. They then hit into the walls of the container harder and more often. This understandably increases the pressure, and if the pressure is too great, the container can burst. Again, think of popping balloons and bursting tires. Ever read on your deodorant can a warning that says not to leave it in the sun? This is because inside the can is a gas, and as we just discovered, heating up a gas causes the pressure to increase and can result in that can exploding. Not a good idea. So what happens if we then cool down the gas? This time, the particles have less energy, and so less pressure is being exerted on the container, which is why balloons shrink and become sad and saggy. Now, it's time for something none of us like. Needles and syringes. Thankfully, there are no injections for us today. We're just learning that needles and syringes work due to pressure in gases. When the plunger of a syringe is pulled out, it causes the volume in the chamber to increase. This increased volume causes the pressure inside to decrease. Now we have created a vacuum that wants to repressurize to normal atmospheric levels. Since it's a sealed system, except for the needle into your arm, the only fluid available is your blood, which gets sucked into the chamber. Your blood then reduces the volume, and so the pressure increases back to normal. Pause the video and fill in the missing words. Did you get them right? So there we have the effects of volume, temperature and molecules on the pressure of a gas. I hope you enjoyed today's lesson, and I'll see you next time.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.
So as you know that the particles in the gas, they are spread out far away from each other. The distance between the particle is too much. So what happens? They move freely here and there. So these particles, they will, while they are moving here and there, they will hit with each other. When they hit with each other, they will start moving more faster, and as a result they will start hitting the walls of the container where it is enclosed. That creates the pressure which is called as the gas pressure. Let us see what happens if I reduce the volume of the container in which gas is enclosed. Volume means the amount of space. Okay, so in the first container you can see this is the amount of space. It is so big, right? And there are only 3 molecules are there in this big space. What I did, with the help of this piston, I pressed the piston down, this grey colored piston. So what happens? Due to this, the space becomes less or more? It becomes less. Space is called as volume, okay? So in less volume, those 3 particles, what will happen to them? They have less space to move around. So while they are moving around, they will hit with each other. When they hit with each other, they will hit with the wall of the container also. Thereby, they will create more pressure inside the container in which they are enclosed. A similar diagram is shown here in the form of a syringe or a piston. This is called as a syringe or a piston diagram. Students, in your higher grades, you will be getting questions of pressure based on this piston only. So try to observe what is happening over here. As you know, there is the rubber cork over here, and here this syringe is closed with a cap. Inside the syringe, there are some gas molecules which is blue in color, which are moving here and there in random motion. Now what did I do? I just pressed the piston and I moved the piston towards inside. So finally what happened? The volume become less or more? The volume become less. Number of particles are same as before. So what happens? The number of particles which were the same, like the same as they were before, they have less space. So they will hit each other more and more. They will hit each other because you know gaseous particles, they are far away from each other. They move freely. So in less space they will move more. They will move, but they will hit with each other more and more, and then they will create more pressure inside the piston. Different volumes with different pressure. Look at this another diagram here. So again the similar thing which I have told you a couple of minutes ago. This is the large container having 1 molecule, and this is the small container. If I put the same molecule in a small container, by increasing the pressure, what will happen? The particle is moving more faster. Can you see this? In this case the particle is moving slowly, and in this case the particle is moving very fast. The pressure is more. So the smaller the container, the higher the pressure. The smaller the volume, the higher the pressure for the gas. So in your notebook, children, try to write all these notes wherever you can see on the top left hand corner, notebook activity. Put them down in your notebook after writing the date, the topic and the learning objectives. All of you are not sending me your work, children. Some of the girls who are sending me the work, they are utterly beautiful work. It's really well maintained notebook, and I am eagerly waiting for such notebooks to give them beautiful comments. Your notebook has to be assessed, and you are going to get some marks on that, children. So please maintain your notebooks with proper date, topic and the learning objectives. Let us see what is the relation between the pressure and the temperature. What will happen to the pressure of the gas if we increase or decrease the temperature? Now, the first container you see, what is written here? It's written here low temperature. Low temperature means less temperature. Less temperature means hot or cold. Less temperature means cold, right? So in this container, this is cold container, right? Temperature is less. Heat is less. And as I have discussed many times before, what is heat? Heat is a type of energy. So in this container where the temperature is less, heat will be more or less. Energy will be more or less. So the lesser the temperature, lesser the energy. So particles, can you see the particles? They are having more energy or less energy? So the particles inside this container, they are having less energy, and you can see the movement of the particles, how they are moving so lazily, clumsily. They feel that they are not at all active, right? But what happens if I heat the same container? When I increase the temperature, when I increase the heat, when I increase the amount of energy, the particles, they get energy, right? They get energized due to increase in heat. So what will they do? They will run here and there inside the container. When they run here and there, they will hit the wall of the container, they will hit the sides of this container. So what will happen? When they hit, pressure is created. This is called as again gas pressure. So higher the temperature, higher the pressure. More the temperature, more the pressure. More energy, more pressure. Less energy, less pressure. Let us look at this bottle, children. So this is the plastic bottle. I am sure after drinking the water from this bottle, you all are doing this fun activities at home sometimes, that you try to just squeeze this bottle by just taking after even drinking, keep on drinking the water, even the last drop is finished, then also you all go on squeezing the bottle by creating some pressure. So when I suck this pressure, when I try to pull this air out, this is the glass tube, okay, and in this glass tube I will try to pull the air out from the bottle by a suction pump, okay. You can just put a vacuum cleaner over here, or we can also take the air out by usual methods, like as we pull the water through the straw. The same way we can just pull the air out also. Now when you try to pull the air out with the help of the straw, what will happen? Inside the bottle, what will be the pressure? The air is less inside the bottle, right? Because I have pulled out all the air from the bottle with the help of the straw. So inside the bottle, the number of air particles are less. But outside the bottle, the number of air particles are more in number. So what will happen? From outside, more and more particles are hitting the bottle, right? They are all hitting the bottle from all the sides. Air from outside is hitting the bottle. So what will happen? What do you think will happen? The bottle will squeeze. The bottle will become crushed. Try this out at home. Okay. This is one more example, children, one more example or one more application of air pressure or gas pressure. When we drink water with the help of the straw, look at this boy, he is taking water, drinking water with the help of the straw. Water or juice or any carbonated drink we drink. So what happens at that time? When we pull this liquid with the help of straw into our mouth, so and on one side you have to remember that first of all we are creating pressure, we are creating a pull force to pull the liquid into our mouth. Adding on to this, the air is creating a pressure and pushing the liquid down. So if there is no air pressure, do you think it is easy for us to pull the liquid inside our mouth with the help of the straw? Do you think, children? If there was no air pressure from here, then it will be very difficult for us to drink the juices and water with the help of the straw. We have to apply lots of pressure, lots of force we have to apply to take the liquid or juice or water with the help of the straw. It's the air pressure which is helping this liquid to go inside our mouth. So here is a quick plenary of what we have done. What causes gas pressure? Just recall what are the things, what are the experiment we have done just a couple of minutes before. what happened, what did we change, what happened when we changed the temperature, gas pressure was increasing or decreasing. It depends upon the amount of temperature. It depends upon the amount of energy. If energy is high, what will be the change in temperature? If energy is low, what will be the change in temperature? Just rewind the slides and just go through and just try to give the right answer. If the gas is forced into a small space, what happens to the pressure? So small space means again volume. Okay, so they are asking you a question here. If smaller the volume, what will be the pressure? Go back to the slides, look at the relation between pressure and volume, pressure and temperature, and try to conclude your answers and put them here in your notebook. So in this way, you'll do all the remaining questions. Once you are done with your answers, try to compare the answers which I'm sharing with you all in the next slides. Okay. Here are some useful links for you all children, along with the link for the quiz. You can just type this on your address bar. Okay. In your laptop, you know what is the address bar on top? On that address bar, try to completely type all these things. Okay, when you type all this, you will straight away reach to this link to solve the quizzes and all. Okay, I hope you understand the topic and see you all soon. Keep yourself safe. God bless you all. Bye.